Hey, how's it going? This is Mr. Miles, and I'm coming at you with an emergency podcast. This is actually doing with the science fair. This comes as a request from a student wanting to know a little bit about more about heat, air, and lift. So I'm going to kind of go over this. It doesn't go into too great a detail, but just enough what they had requested. And again, just a reminder, if you guys do have any questions about your science fair projects and want a podcast, maybe explaining something or different things that you can look at, I will keep it anonymous so that way nobody can come and try and steal your idea and start bugging you about it. And if you guys do decide to do something on heat, air, and lift, already somebody is working with this stuff. Now, there are plenty of other things that you guys can do besides what this young lady is doing. But if you want to, just make sure you come and clear it with me so I make sure you're not doing the exact same thing, and we'll get it going. So if this thing would let me go to the next slide. There we go. All right, awesome. So the question posed was, why do hot air balloons work? How do they work? So here's my ugly picture of a hot air balloon. There's the fire going out, and here it is creating lift, and there's your lovely basket that we float in, and we smile and look down at the world. And the question is, what exactly is going on here that's creating this lift? Well, what we got to do is we got to go on small. Very, 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 very small. So small that it just boggles your mind. And the unit that we're going to be talking about is we're going to be talking in atoms. Now, some of you are very familiar with atoms. You learned a little bit about it in elementary school. You guys will learn about it more in 8th grade and more in high school and college. Now, atoms, if you remember, are made up of the tiniest known particles. I mean, there are, physicists and people like that who say, hey, we got things smaller. But for right now, and what we're going to teach you, and not to blow your minds or anything like that, is we're going to talk about electrons, neutrons, and protons. Now, all of these together, they will make an atom. And an atom does not just sit still. An atom is like a child with ADHD. It needs to always be moving. It needs to always be moving, and it always needs space to move. The best way to think of this is it's at a dance. So these atoms are at a dance, and they're always constantly moving. Now, if it's cold, they don't move that much. They still will move, but until you hit 0 Kelvin, which nowhere does, the atoms are always going to be moving. Now, as it gets hotter, the atoms need more space to move. So think of cold would be like a slow song, one of those R&B songs, and you're just kind of swaying back and forth, having a good time. You find a cute girl and say, hey, what's up? Look at my awesome picture of you guys saying, hey, what's up? And you're going to be moving slowly. You don't need that much space to move around because you're dancing slowly and you're not really bumping into each other. Now, all of a sudden, hot comes on, and they play a face-melting guitar solo. I'm talking about like a hairband, heavy metal, fast psycho solo on the guitar. And you want to start dancing like crazy. You go nuts. And you're bouncing around, you're mosh pitting, you're bouncing off people, and you need more space. The same dance hall that you thought was big enough for you and all your friends now isn't that big because now you're even bouncing off the walls. Now this is what happens when you take any substance and then you start to heat it up. It's going to want more space because the atoms want to move more. Now with a hot air balloon, well, first let's look at a balloon. So a balloon, if you've ever noticed, you can take 2 balloons, take this one and fill them up. And you'll see them both, make them about the same size, and heat this one up. Heat this one up, and you'll notice that the balloon will start to expand out a little bit bigger than this one. The reason is because those atoms start bouncing up against it, and they're trying to escape, but they can't because the balloon's trapping them in. And so they're trying to expand. Now, in a hot air balloon, however, when they try and expand and when they're trying to bounce out, there is a place that they actually can go out. They can find their way out here. But at the same time, when the air actually expands, it becomes lighter. So you guys know the saying, like if your house is ever on fire, you need to get down on the ground and as close to the ground as you can and get out. Because as the air heats up, it becomes lighter. That's why your attic is always the hottest place in your house, because that air is lighter. And believe it or not, air actually weighs something, because remember, it's made out of matter, it's made out of atoms, so it does have a weight, a lot less weight than we would have. But it still weighs something. But as it heats up, that air becomes lighter because the atoms become more spaced apart. So because this is now lighter than the air surrounding it, so here's all the air surrounding it, it creates lift. It wants to go up because this is lighter and this would be heavier. You can see the same effect as if you were to take a basketball and try and hold it under the water of your swimming pool. Because we know that air obviously is a lot lighter than water, the air wants to rise. The same thing happens with bubbles. Because the atoms are a lot more spaced apart in air, it's going to want to rise out of the water. Now, if you want to just launch that ball out like a cannon, just heat up the air even more, and it's going to want to fly out even higher and further in the water than if it's just colder air or room temperature air. And that's kind of how hot air balloons are going to work. Is as that fuel source, that fire that you have at it, is blowing it out. It's heating up all the air around it, making it lighter. Now, the balloon isn't just going to expand till it pops, because there is actually a way for some of the air to get out. But because now this air in here is lighter, it's going to create that lift. It's the same effect as the basketball in the water trying to get out. And so the question posed there is, how much air do you need to create a certain amount of lift? And then the other thing is, can you affect the lift by how hot you make the air? So you can ask yourself, if I heat up air 3 times the amount of what it normally is, how much more lift will I get if I do it 6 times? Will it double the lift? Will it triple the lift? And that's a question you can ask yourself, is how much does heat and how much does the amount of air, how big is the balloon, how is that going to affect the actual lift? And so that was just a brief little thing on heat, air, and lift. So if you guys, again, if you have any questions about this or want to know a little bit more, just feel free to ask me, and I'll make sure that I put up another podcast or something like that. And for anybody else who's doing anything different, make sure that you guys let me know in class, and then I'll put up a little emergency podcast for you too. And so hopefully that'll inspire some other people. So, all right, until next time, I will talk to you later.